Compute the fundamental group and Euler characteristic for a sphere with two glue points. Let's look to the proof. So Euler characteristic first. Consider the sphere and the CW complex decomposition of the sphere that includes the 2 points that you want to glue, these two antipodal points. So the CW complex decomposition will be given by the 0 cells, the 2 points that you want to glue, 2 1 cells on the circle that is the middle circle of the sphere, and 2 2 cells given by these parts, this and this. So the Euler characteristic of the sphere can be computed like 2 minus 2 plus 2. But now the sphere has 2 glue points, so we glue these 2 points. So this means that we lose a 0 cell. So the sphere with 2 glue points will be 1 0 cell, 2 1 cells, and 2 2 cells. And this means that the Euler characteristic of the sphere with 2 glue points will be 1 minus 2 plus 2, which is 1. If we look to the fundamental group, we use the following condition, theorem. A contractible subcomplex of a CW complex X has the property that X quotient X goes to X quotient A. It's a homotopy equivalence. So we in a CW complex we can quotient contractible subcomplexes and obtain the same relation. So A1 it's homotopy equivalent with a point, A2 it's homotopy equivalent with a point, A2 it's an arc, one cell that connects the 2 points that you want to glue outside of the sphere, and A1 connects, it's a one cell that connects the 2 glue points on the sphere. So A1 it's on the sphere, A2 it's outside the sphere. Both are contractible to a point. So according to the theorem we want to use, X quotient X goes to X quotient A1, it's a homotopy equivalence. But what is X? So here X is the X is the entire picture. It's the entire picture of A2 and the sphere. So when you quotient to A1, it means that you actually glue all these points along this line. So what you will obtain in the end, it's a sphere S2 wedge S1, which will be this circle outside of the sphere S2. If you take the map into X quotient A2, you will actually contract the exterior arc, the exterior one cell to a point. So then you will obtain S2 with 2 glue points. So according to the fact that this is homotopy equivalent and this is homotopy equivalent, it will imply that S2 with 2 glue points, it's homotopy equivalent with S2 and S1. So this means that pi 1 of X quotient A2, which is pi 1 of the sphere with 2 glue points, it's actually pi 1 of S2 wedge S1, which implies it's a Z, it's pi 1 of S1.